branch is having a resistor 30 ohm and a coil. Coil is the inductor. So that is given 127.3 millihenry. And they are connected with the 3 line. And this is a star connection. Okay. So now the information given on the question paper is the current is given. So these are the branches and the current, line current is given here. And what we have to find out, calculate the line voltage if the supply frequency is 50 Hertz. So here frequency, we need to know the frequency. Why? Can anybody tell why we need the frequency? Yes, so inductive reactance. So here you see this resistance is given in ohm, is the unit is ohm, and this inductance is millihenry. So we cannot do anything if it is millihenry. So that has to be converted in ohm. So how to do that? We can do this by calculating the inductive reactance. So XL we can write down, and that will be given by, the formula is given 2 pi FL. Okay, so if I write down this one, that will be 2 pi, F is 50 Hertz, and L is 127.3, 10 to the power minus 3. And this will become ohm. Okay, so now these two becomes same unit. So what is the value? Can anybody tell me? Hmm? 39.99 ohm. So I can now consider these two elements of same unit, and we can find out the resultant. They are connected in series, so I need to add them. Now one of these component, if we remember the impedance diagram, then this is my resistance, and XL will be in upward direction, right? It's the downward direction. Current is lagging, so V divided by, it will be downward direction, right? Current is lagging, so I will have this one will be downward direction. No, this will be upward direction because it is R plus JXL. So we will have this one will be the upward direction. So this will be XL. Okay. And this will be my, so these things we have to remember. So this is XL, but if you have a capacitor, that will be downward direction, XC. And that will give me the impedance Z, so theta. Okay, XC will be downward direction always, and XL will be the upward direction. So for this one, I can write down Z will be equal to, how can I write down? R plus JXL. So XL is 90-degree phase shift. And this one would be Z equal to R minus JXC. Okay. Now, if you have both the component, then we can find out the resultant, JXL minus JXC. So you can just write down, if I have two components, both XL and XC in my circuit, then I will have XL and maybe XC in this direction, And then we can find out the resultant here between the XL and XC. So it will be XC minus XL, and then Z will be here. So Z, we can write down R minus J XC minus XL. So this is not always will happen because XL may be larger. So in that case, if you have XL is larger, then we can redraw this one. So if you have two component, you need to take a look which one is larger. So if you have XL is larger and XC is smaller, then your resultant will be in the XL direction. So it will be XL minus XC. So your Z will be this one, and this will be, Z will be equal to R plus J XL minus XC. Okay, so these are the four scenarios that we can have. So we can have only, for our case, I have only the inductive reactance. So this is true for this particular example. But if you have a capacitor, this capacitor will be given by R minus JXC. So it is lagging, okay? And then your impedance, you can have two types. This is the first case where your XC is greater than XL. So if you have a scenario that your XC is greater than XL, then your vector XC will be larger and XL will be smaller. So your resultant will be XC minus XL. It will be in the direction of XC. And then if you add these three, then you will find out Z, and that will be given by R minus JXL. So minus J indicates the phase shift of minus 90 degree. So that we know, right? So J is indicating that Z is always indicating the angle of one angle of 90 degree. So J is indicating. So this vector is actually making an angle of 90 degree with the reference. If this is my reference, this is making an angle of 90 degree. And this is the positive angle. So that's why it's plus J. Right? So this is the positive angle, right? Positive 90 degree. And that is indicating by plus J. All right? So I have written this one, R plus J XL. So XL, R and XL are not in the same line. R is the reference direction and J is making an angle of 90 degree with the reference, and XL is in the perpendicular line that is indicated by this one, that is in the upward direction. Minus indicates minus 90 degree. That means in the downward direction is the lagging angle. Okay. And the second case, we might have three components here: resistor, capacitor, and inductor. And if you have the inductive reactance is greater than capacitive reactance, then I will have this scenario. So this will be XL, and this will be my XC, and XL is greater than XC. So your resultant is XL minus XC. So that is given by this one, and it will be in the direction of the larger quantity. Okay, clear? Any question? Are you following? Following? Okay, so for our case, we have only this scenario. So we'll consider only this case to find out the impedance. So impedance is required to find out. So these two, equivalent impedance of these two, I have to find out for each of these branch. So these two equivalent impedance. So they are connected in series, but this is a vector quantity. So you have to find out the impedance using the vector. So that's why I need to write down R plus JXL. So if I write down my impedance, Z is, we can find out is 30 ohm plus J of 39.99. So you can convert this one to polar form to do further calculation. Can you do this polar form? What is the value? Anybody has done? 13. 49.992 at an angle 53.02. And this is, what is the unit? Rajesh, ohms. Very good. Okay. So now we can redraw my circuit because we have found the simplified form. So 53.1 is fine. Yeah. So we will redraw the circuit to simplify our. So this is my Z now becomes, and this is composed of all the quantities. Then I have the other Z is connected with the other phase, and this is connected with my third phase, and I can show this three phase as A, B, C. Now, so all of them are having Z, right? Are you writing? Sure. So what is given in the other quantity is, so here is given the line current. So we need to identify the line current. So if I identify the line current, this is my line current, and that is given, say IA, that is given equal to 5.08, right? And the angle has not been mentioned. And this one is given equal to, similarly IB, and that is given equal to 5.08, right? And this one is the third quantity, that is equal to 5.08. Now, what we want? We want the voltage, line voltage. So what we will do? Any idea? Yeah. Everybody has got this? So this current is passing through this line. This is actually coming through this phase, right? And this phase I can identify is I theta A. And this phase, this current IB is coming through this phase, and that can be identified I theta B. And this one will be I theta C. Now I know this current and the voltage. So we can find out the voltage. We know the current and the impedance, right? So then we can find out the voltage. So here we can assume the current angle, because current angle is not given, only the magnitude is given. We can make our assumption of the current angle because we know this current, line current, will be phase shift of 120 degree each, right? We can take reference of any current and then we can find out the other current. So then at the same time, we can consider everything. Otherwise, we have to readjust at the end. So I will prefer to consider that IA is equal to 5.08, and this is my reference point 0. Okay? And this is my assumption. I have taken this assumption. IB will be, I'm talking about ABC sequence. ABC sequence. So that means B will be the next quantity, and that quantity will be, so this is my assumption. As it has not been mentioned, but I know that our line quantity will be 120 degree away apart, phase shift. So I can make this assumption. So that will not change anything. So this one will be minus of 120 degree, and IC, I can consider this one is 5.08, making an angle of plus 120 degree. Okay. Now we can find out my V theta A. Okay, so V theta A, where is V theta A? V theta A will be plus, this will be my plus terminal, and this will be my, so it would be actually, I have given the wrong angle. This is a load, right? So I should have drawn this one. This direction of the current in the load, current should be entering. So I will just remove this one also. So I have to consider this current is entering. So then this will be positive, and this will be my negative terminal. So this is a passive component. So this will be my negative terminal, and this is my V theta A. So similarly, for the other phase, I will make the correction, and this. Okay, so this one, now I have to have one more. Okay. So this current is entering. So this current will be entering from the generator. So this will be also entering. And then this will be entering, and this will be entering. So this one will be positive terminal. This will be negative terminal. This will be V theta V. And this will be my positive terminal. This will be negative terminal. This will be V theta C. All right. Following? Okay, so now we can find out V theta A. So V theta A would be equal to IA times Z. And that we have found, this one is 5.08, making an angle of 0 degree, will be multiplied with Z. So what is Z? It's 49 point. What is the value we have found? 49.992, making an angle of plus 53.02. So if you do this multiplication, what would be the value? 253.94, making an angle of 53 degree, right? Right? Now we need to find out, similarly, we can do this calculation for each of the phase, or we can just add 120 degree with this one. So that will give me by V theta 2. So V theta V will be, I know this will be the same value, right? 253.94 will be the same value. Now this angle will be changed. So this will be plus 53.02, and with this I have to, this is theta B, so it will be lagging, that's why minus 120 degree. Okay, so that will give you 253.94, making an angle. What is the angle? It's 98 and 52 or 62. What is the angle? Minus 66.98. Okay. And then we have V theta C would be equal to the same 253.94, and this angle will be plus 53.02 plus 120. So that will be 253.94, making an angle of 173.02. All right. All right. It's done. Or do we need to do anything? All done? Line voltage. So this we have calculated only the phase voltage. Okay. So now we need to go back to our circuit and my line voltage. So we can consider my line voltage between these two lines as VAV, or in simply I can write down this is VA. So this letter indicates this terminal is positive. So similarly, we can have this voltage as VBC, and the other quantity from here to here, we will consider this is VCA, or equal to VB, or equal to VC. Okay. Now how we will find out? To try to find out VAV. What is the equation for VAV? How it is related with VAV? We can write the equation KVL, right? So how to write down the KVL equation? Yep. So we can consider only for one loop we can consider. So that is my VA, theta A. And that we have considered, this is my positive terminal, this is my negative terminal. And then we have V theta B. If you are not following, just let me know. So this is my positive and this is my negative. And then we have considered this is my voltage VAB. Whenever we are writing VAB, that I am mentioning again and again, that A terminal we will consider my positive terminal, and this one will be my negative terminal. This polarity we are assuming because AC doesn't have any, it has the polarity, but it is alternating, it is continuously changing. There is no fixed polarity for AC. But for the sake of writing my equation, I am taking any of the polarity. Between two polarities, I can consider one of the polarities. Now in this loop, I can apply KVL. If I go counterclockwise, then I can write down KVL at this loop. What would be the KVL? All of you should write down. What would be the KVL? with the sign. With the sign, let us write down with the complete one first. So what is minus VAV, V theta A, V theta V, very good. That is equal to 0. So then I can simplify VAV is equal to V theta A minus V theta B. Now we know all the quantity with the angle, so we can do the addition. So this is 253.94, 253.94, making an angle of 53.02, and then minus 253.94, making an angle of minus 66.98, right? Now we can go as we have done in the previous class. We can use the phasor diagram, but I think we can do it directly as Osman has suggested. And in order to do directly, what we need to do? Yes, so you need to convert it to the rectangular form, because the polar form we cannot do the addition. They are not good for addition. So they are in polar form, they are not good for addition, so we have to convert it to rectangular form. So if we do the rectangular form, then what would be the value? All of you should be active. You have to write down as well as do the calculation by yourself. So that will make you more confident, more competent. Now, if you just see and you don't do it by yourself, then you will be always lacking of confidence in doing. So once you do with me, and if you go home, try to do it by yourself once, that will be enough for your understanding. So what is the value? Who can tell me? 152.75 plus J 202.86, and then it would be minus or plus. So let's write this minus sign, and then inside we can write down what is the conversion. What is the value? Second value. This is the resultant of these two, or what? So this is not the complete result. This is the partial result. This is the complete result or no? So what is this value? 99.3 minus J 233.72. Now if you do this addition, so it would be 152.75 minus 99.3 plus J 202.86 plus plus 233.72. So if you add, yeah. So if you add them, so what is the value? 100 is 52, 51 point something. 53.45 plus J 436.858, right? Yeah. So then you can convert this one to polar form. What would be the value of the polar form? Hmm? 439.84, 83.02 degree. Okay, so this is my VAV. Now what we can do, we can find out, we can do the similar for the other phase. You can do all the calculation, or we can just convert using the similarity or analogy. Because of three phase, there will be 120-degree phase shift. So using that one, we can find out the next quantity. So VBC would be equal to BV, and that will be equal to VA, making an angle of, it will be VA's magnitude is same, and that making an angle of minus 120 degree. So VA is actually 439.84, making an angle of 83 point. So is that VA is actually, yeah. So 83.02, and then I have to add, that means this one will be subtracted by 120 degree. Okay. Do you understand this one?
Yeah, I just went wrong with the cup.
Where? I have not done the calculation. It's all false with no clue. So I think it's fine. You got the same, right? Which one? The angle. So what is the difference? Yeah. So if decimal can be different because you are changing the most significant bits, digits.
Yeah, no, I've got the same answer as Jared, but so what is that? The negative 99.3 minus J
233.72.
Yeah, I'm lost at that part.
So you got 99.3 minus. What is the final result? Tell me, what is the polar form of the final result? You have got the final result?
No, I haven't got that.
You just continue. You just continue. So what is the value? You got 253.94 minus 66. That part is fine. Yeah. So then you convert it to rectangular form. So that part rectangular form, what is the value you have got? 99.3 you have got?
Yeah, well, mine's 99.72. So I'm doing it.
99.72 is fine. Yeah,
See,
the next.
I know what I'm doing wrong now. I was doing, you guys were taking A or B, but I did the ABC sequence differently. So
Okay.
in the opposite direction.
Yeah, if you understand, that means you have taken ACV sequence, right? Yeah, that's fine. If you follow that one, if you can continue, that's fine. There is no harm because here it has not mentioned that it should be this sequence, but you can assume any sequence. I have taken this is ABC sequence. That means from A, B is 120-degree phase shift minus 120, and then C will be plus 120. But you can also take C is minus 120 and B is plus 120. It's the same. You will be right. You will be right, but result might be slightly different. Okay.
That's what I did. I was getting a number that was way
Yep.
different.
So this is the general information that if you are following different, just mention which sequence you have followed. Don't be worried. Don't be puzzled. Try to continue. So as long as you are following the right steps, you will get full marks. Okay. Okay, so then this one will be this value, and then it will be 439.84 and making an angle. What is the angle now? Now Noku will not tell me. He will be telling you or blaming me. 37 point minus 37.88. And then VCA will be doing the same. VCA equal to VC, and that will be equal to VA, and that angle will be plus 120 degree. So that will be giving you 439.84, making an angle of, so what is the value? Is this one, right? So this one is 83.02 plus 120. So that will give me 439.84, making an angle of 203.02. All right. Okay, now phasor diagram. Phasor diagram of the voltages. You should all be able to draw the phasor diagram of the voltages. This is not asked in the question, but it may be asked. So always we will do the phasor diagram. So for this one, phasor diagram of currents, there is no complexity, right? So it will be the both phase quantity and line quantity will be same. But here it will be different with the phasor diagram of the voltages. Of voltages. Can you draw the phasor diagram? We have all the angles are given. So you can easily draw the phasor diagram of voltages, right? All the angles are given. Now we need to check whether we are getting the 30 degree between phase angles, phasor quantity and the line quantity. We have found V theta. So we need to just represent V theta A. We have found equal to, what is the value? 253.02, making an angle of plus 53. Am I right? So 253.94, making an angle of 53.02, right? And then we have V theta, sorry, V theta B, we have found 253.94, making an angle of 66.98, right? And then we have found V theta C is equal to 253.94, making an angle of, what is the angle? Final one is 173.02. 173.02. So all are degree. So then we have found VA is equal to 439.84, making an angle of 83.02. Okay, so these two, if you compare these two, angle is 30-degree phase shift. Okay, so that is correct. That should be the line quantity and phase quantity should be 30-degree phase shift. The second one, we have found 37.88. So that is slightly different. So 439.84, and then we have found minus 37.88. And then we have found the last quantity VC is equal to 439.84 at an angle of 203. 3.02. Okay, so we know all the quantity. Now we need to just draw them in a diagram. So all the quantity and their angle is given. So you draw it. All right. Any question? This is Abhishek. Who is Shivam? Shivam, you. Okay, I just memorize your face. Scan. And then you are Asha. What is your name? Ansh. 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 All right. Have you done? I think I don't need to draw it, right? Do I need to? Yes, please. This is straightforward. You know all the angles. You just need to draw. Okay, so we will take the reference. For this one, we will take the reference. It can be always references in the horizontal line. Now, if you consider, let us draw in different color. So we will consider first the phase quantity. It starts with, so this one is minus, right? I think I have done wrong. Yeah. So this is 53.02 plus. So that means I will have a quantity, something like this one. You don't need to be exact, but this angle will be 53.02. And this will be V theta A, right? And then theta B, this B theta B will be minus 66. That means from this reference, we have to go in the clockwise direction. So this will be something like this. And this will be V theta B. And this angle, we have to mark, this one is minus 66.98. And the last one is 173 positive. So that means we have to go this way. Probably 180 is the straight line. So it will be slightly upward direction. And this will be my V theta C. And this angle will be 173.02, right? All right. Now we will draw the line quantity. So first one is this one. This is coming. So we'll take, I think this one is good. So 439, the magnitude is larger that we need to show, and 83.02. So 83 from here, we will go another 30 degree. Is 83 is 90 is this one. It would be somewhere here. And this is a large quantity, VA. And this one is 83.02, right? Yeah. Okay, then the second quantity, V theta B, is 37. So it will be somewhere here, VB, and this will be minus 33.88. Okay. And the last one would be somewhere here. So this is VC, and that will be, angle will be 203. So I have gone further, 80 is fine. So this one would be somewhere here. This is 203.02. All right. Once you have calculated, then it becomes easy. So here doing the calculation, first thing is this calculation is critical. You need to practice. And then this angle, you need to keep in mind why I have written this one. So how I have written, I think all of you have understood, right? So this one, and then from here, you have to just calculate this one. So if you know these things, then I think it's easy. Now for the current, it will be the same, right? We have assumed my line current, that was IA, and that was my reference. And then we have IB, and then I have IC. And this will be the same as I theta A, I theta B, and I theta C. Okay. All right. Any question? So we can stop this.